Okay, today we'll discuss templates, including template functions and template classes. This also this is also called generic programming. Generic means typeless. This is also called typeless programming. We had discussed function overloading, which means we can have multiple functions with same name, but they will differ on the basis of number of arguments or on the basis of types of arguments. For example, let's write a function integer sum, integer a, integer b, return a plus b. Similarly, we can have a function float sum, integer sum I. Oh, wait a minute. It should be float I and float j. Return I plus j and so on. So now here we have two different functions with the same name sum. They differ on the basis of number of arguments or on the basis of types of arguments. Like in this case, these two are different on the basis of types of arguments. When we have to call these functions, cout sum 1020, then the first function with integer parameters will be called. And if I write cout sum 10.4 and 12.8, something like that, then the second function with float parameters will be called, right? Actually, instead of float, we should make them double because these literal values, real literal values, are treated as double, not as float. Okay, I think it will work now. Fine. Let's run this. You can see we have got the results here. So we are having two functions here with same name, but they differ on the basis of types of parameters. And this concept is called function overloading. Now, generic programming using function templates or class templates is just the opposite of it. It means we'll create a function which can work for different types of data. For example, have a look here. So for creating any template function or template class, first we need to write template. Then within angled brackets, you will write class and give it some name. It may be T, A, B, C, whatever you wish, doesn't matter at all. Now, what does it mean? That we have defined a generic type T. You can use here class or you can even use here type name. Doesn't matter, it's the same. So what we'll do, we'll use this generic data type everywhere in the function. Okay. So now this sum function is not bound to any one particular data type, to integer or to float or to long or to double. No, it is a generic one. Like here, as you can see, when I am calling this function with integer parameters, it's working. There's no error. When I'm calling this function with double parameters, it is still working. This single function will work for both the calls. Let's have a look. Let's run it again. Here, you can see the result is the same. Okay. Now, this function will work for different types of data. For example, even we can declare like this integer I1 is equal to 10, I2 is equal to 20, float F1 is equal to 12.4, and F2 is equal to 14.9 or something. Double D1 is equal to 12.12345 or something. D2 is equal to 3.4567 or something. So here we can write some I1 and I2 will work for integers. We can write F1 comma F2. It will work for floats. Cout some D1 comma D2, and then it will work for double as well. The same function will work for three different types. This is how it will look. Is this thing clear to all of you?
Yes, sir.
Okay. Now, if you look at it, here we have declared one generic type. It means this function can handle only one data type. Uh, like here we are passing two parameters. Both the parameters should be integer or float or double. They should be of the same data type. If I try to mix it, Cout some I1 with F1 and then will it work? Have a look. No. It is giving an error message because we are having only one generic data type. So to overcome this, let me create two different and class T2. Here T1, T1, T2. Look at it once again. The next one, the last function, fourth one, where we had mixed the data types. Now it is working. There's no error now. T1 will correspond to integer, T2 will correspond to float, and its return type will be integer. Let us check it again. Here, you can see we are adding I1, that is 10, and F1, which is 12.4. Since its return type will be T1, T1 is corresponding to integer, it will return 22. Now, instead of T1, if I make it T2, it means it is corresponding to float now. Have a look. What will be the output? This time it is saying 22.4, right? 22.4 because T1 corresponds to integer, T2 corresponds to float, return type is T2, which is float, so it is returning a float value. Is this thing clear to all of you, bache? Yes, generic
Yes, sir.
functions,
Yes, sir. Yes, sir.
template
Sir,
functions.
थोड़ी आवाज properly नहीं आ रही.
Bache, I can't help it. I am using the best possible connection available here.
Okay, sir.
Okay, a very, very important thing. When you have declared this template here, after this declaration, the next declaration should be of a template function or template class. You cannot declare any other variable, for example, integer a or anything here. If we do this, it will cause syntax errors. So it's clear that after template declaration, there should be a template function or template class. Up to this point, if there's any problem, something is not clear, then let me know. Yes, if something is not clear, then let me know. Up to template functions. Yes, anybody? Any problem? Should we move to the next topic then? Template class?
Yes, sir.
Okay. Have you done stacks? Have you done
Yes,
stacks
sir.
data structure?
Yes, sir.
Yes, sir.
Okay, fine. First, let us take up a simple example. Then we'll create a stack class using templates. Okay. So once again, template class T class some temporary class. Let's create PA public void display. And here we'll write cout A and then okay. It's a very, very simple class. What we have done, we have declared a generic type T, declared a class. Now T, this data member A is of generic type T, and then we are displaying it. Now, when you are to create objects of this template class, For example, here I'm creating T1, right? So let us have a constructor as well. Temp T sum x, A is equal to x. Okay, fine. Now here I'm passing it a parameter 10. But you can see here there's an error. What we need to do at the time of creating any object of a template class, we need to specify the type for which we are creating it. Like I have within angled brackets, I have written T, int. It means the type of class that I'll create, its data member will be of type integer. And then T1 dot display, small t. Okay, T1 dot display, let's run it. Is displaying value 10. Now using the same class, if I create another object of type character, I have not done anything in the class. I have just declared the object with a character type specifier. It works for a character. Similarly, if I make it double, it will work for double as well. Here, it's working for double also. This is a very, very simple example of template classes. Is this thing clear? Template class is clear?
Yes, sir.
It's a very, very simple example. Okay. Now coming to stack class. uh, have you done applications of stacks?
Yes, sir.
Which one you have done? Applications of
In fix.
stacks. Now
In
let us
fix.
take a very simple one. Reverse a string, right? Infix to postfix, and there one more is there, that is
Parenthesis matching.
postfix evaluation. Okay, fine, we can write that also. Parenthesis matching. Okay. For reversing a string, the type of stack should be character. For parenthesis matching, type of stack should be character. For infix to postfix, gain character. But for postfix evaluation, it should be some numeric type. Am I right? For postfix evaluation, the type of stack should be numeric. Suppose you are to implement these different applications or these different algorithms. So you need to have at least two types of stacks. One for character, another for numeric. It may be integer, it may be float or double. So instead of implementing two different stacks, let us have one single stack generic using generic programming. Class T, integer n. Okay. Then class stack. We need to declare a top. It will definitely be integer only, right? Integer size is equal to n, or we can set it later also, or we can set it here also, doesn't matter. Okay, then we need to have p data of n number of elements. Basically, there are two data members. Let's remove stack size from here initially. Top, that is the top pointer. It specifies how many characters are or how many elements are there in the stack. Then an array or a pointer that specifies how many elements can be stored in the stack or size of the stack. That's why I have taken the size also. Okay. Now, let us create the default constructor for this. 1. Size will be set equal to n. I think this much is sufficient. Now, there are two different, earlier also when we started with classes, I had told you that there are two different methods of defining the member functions of the class. Let us write tool. We'll discuss. The method of defining a function outside the class is entirely different in case of templates. I'll tell you. Let us write the required functions first. Tool is full. Then void push t value and t pop, and let there be another function t peep. I hope you understand the difference between pop and peep. Do you people know what's the difference? Pop means remove the element. Peep means just check the value of the top element without removing it. Okay?
Yes, sir.
Okay. This is the class declaration. So look at this. If you are to define a member function within the class, it's just like the normal class. But if you are to define a member function outside the class, then the method is different. Let me show you. Every time when you are to define a member function of the class, you will have to write template class t integer n. First is bool. Name of the class is stack en. Then is empty. How do you check whether stack is empty or not? If top is less than equal to -1, means stack is empty, otherwise is not. Similarly, template class t integer n, bool, name of the class t, name of the template parameters, and then function is full. How do you check whether a stack is full or not? If top is greater than equal to size -1, return true, otherwise return false. Okay, then next function, again template class t integer n, void push, name of the class, then parameters, resolution operator, push t value which is to be pushed. If not is full, what happened? Push, okay, fine. If the stack is not full, then how do we push an element into the stack? Yes, anybody? How do we push an element into the stack? We'll increment the top, and after incrementing, we'll store the value at the array index. Okay. Again, class t integer n, and t for pop function return type will be t, name of the class n pop. If not is empty, if the stack is not empty, return data top minus minus. First we'll return the value, then we'll decrement the value of top. Okay. Similarly, for peep, we'll use the same function. There's only one change. In case of pop, you will decrement the value of top, indicating that an element has been removed. But in case of peep, you will not decrement the value of top because you are just specifying what values lies at the Fine. So this is the whole generic stack class. Now let's use it. Stack integer 10. iStack. I'm naming it iStack means integer stack. Stack character 10. Stack means it is a character stack. Similarly, stack double n d stack. So using one single class, I've been able to create different types of stacks. Now let's try these. For integer I is equal to 0, I less than 10, I plus plus. Let's insert different values into these stacks. For example, I stack, we can insert integer values. Dot push. I will insert I itself, okay? And C stack dot push. Since it is a character stack, I insert A plus I. So it will be A, B, C, D, and so on. And in double stack, I will push some values. For example, let us say I divided by 2.5. Let's say hypothetically some values. So 0 by 2.5, then 1 by 2.5, and so on. Those values will be inserted in double stack. Okay, now let us print all these values. While not I stack dot is empty, till the stack integer stack becomes empty, we will write cout I stack dot pop little space, that's all, and then cout and then. So we'll print the values of I stack one by one. We'll pop the element and we'll print it one by one till it becomes empty. Let's use the same logic for others. Next we had C stack, and similarly we had double stack. Let's run it. See what's the output. Here it is. If you look at this, look at the first case, we had inserted 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So when you will pop out the elements will be in reverse order. Similarly, for character stack, we had inserted A, B, C, D, and so on up to J. A, B, C, D, E, F, G, H, I, J. 10 elements. So elements will be popped out in reverse order, just in the same way for double. So you can see we have been able to use this stack. We have been able to use this generic stack for different types. Is this thing clear? I'll share the code with you if you want. Is this thing clear to all of you?
सर पुश वाले एलिमेंट्स का तो पता नहीं लग गया.
Beta dekho, have a look at it. We are using I everywhere in all these three different push, right? I's value will iterate from 0 to 10. Okay. If you look at the integer stack, look at the first stack only. So what we are inserting 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? We are inserting value of I. Now in case of the character stack, I hope you remember we had discussed this thing in class, how it will work. Within quotes I have written A plus I. Now we are inserting a character, right? A plus I means 0 initially. A plus 0 is A plus 1 is B, A plus 2 is C, and so on. So A, B, C, D, E, F, I, J. These values will be inserted, right? Similarly, for double stack, what I have done, again, I am using value of I and dividing it by 2.5 just to generate any kind of values, right? So these different types of values, integer, character, and double will be generated and inserted into the respective stacks. Okay? In case of I stack, it is integer, C stack, character stack, is D, it means double stack. So once the values have been inserted, one by one, we will print the values by emptying the stack. Call the function, call the function pop repeatedly till the stack becomes empty, and we are implementing it for all the three types of stacks you can see here. Is this thing clear now?
Yes, sir.
Okay. Here's a little modification. Let me show you what you can do. Let's go to the top of the class. Fine. Here, what I can do here, I can write is equal to int. It means by default the type is int. Similarly, n is equal to 20. By default the size is 20. If I do it like this, then what will happen? Look here. I'm declaring one more stack without passing any parameter, and I'm naming it G stack. Or you can name it just anything, right? Even if you're not writing it, let's see whether it will work or not. No, you will have to write angle brackets, but without passing any parameter. Earlier we were passing a type and size as parameters, but now since we have declared default types for these, right? By default, t is integer. By default, and size is or n is 20. So when you are not passing any parameter here, its type will be integer and its size will be 20. Let's write here g stack dot push. I can write I plus 100 or something, whatever you wish, any values. And then similarly here, let me print the values of g stack, this general stack. Let's run it. So second one we have called, it is printing the values in reverse order. We have added just 100 value to integer I. Is this thing clear?
Yes, sir.
If
Yes,
you
sir.
have if you have any kind of problem, then let me know. If you have any kind of problem with this, then let me know. Using this
No, sir.
generic programming, using template functions and template classes, a standard template library has been created. We call it STL, right? So it contains generic types or generic data structures, and it also has generic algorithms. Generic algorithms like we have uh, QSort, research, quicksort, and binary search algorithms. These will work on any type of data, right? Similarly, generic data structures, we have stacks, we have lists, and even before that, we have vectors and so many other things. We have queues, we have all these different data types. Do you have any idea what is a vector in mathematics? Do you have any idea what is a vector? Anybody?
Something related to size.
Something related to size. Good. Anybody else? Yes, anybody else? Andri, anybody else? What is a vector? Okay, let me show you. Let me show you what are vectors. As I told you, it is an inbuilt, just a minute. A vector is an inbuilt data structure. It is covered under standard template library. Okay. Here, look at it. The way you declare an integer array, suppose some array you have declared 10. Now the problem with this array is, first you have bound it to a type that it will always be integer. Second, you have bound it to a size that it will always be 10. And I hope you remember that in case of arrays, the size is fixed. You cannot change it later on. Okay, it is not possible. An alternative of this, which will cover both the problems of it, of type and of size, is vector, which is defined in standard template library. You have a look at it. I have declared two vectors, integer iv1, integer vector iv2. I have declared two vectors, and then this is an iterator. Iterator means, for example, here, in case of array, you use a for loop for integer I is equal to 0, I less than some 10, I plus plus, and then you iterate through the values. For example, cout array I. So what you are doing here, you are iterating through different values of this array, this integer array. But in case of vectors, it is not that simple. We need to declare its own iterator, right? So look at it. Let us run this program one statement at a time. Let me remove all these initially. Okay, fine. What we have done here now, we have declared two vectors, iv1 and iv2, and an iterator, it. We are checking what is the size of iv1 and what is the capacity, right? Size means how many elements you have stored. Capacity means how many elements you can store. So there is a little difference, right? Like in the second statement, we are reserving 100 elements for it, and then again we'll check what is the size and what is the capacity. Let me put a pause here. Okay, let's run it again. You can see here, initially, when we have simply declared the vector, its size is 0, means no element has been stored in it, and its capacity is also 0, means maximum that you can store is 0. After reserving some space in it, its size is 0, means you have not stored any element till now, but you can store maximum 100 elements into it. So this is the difference. Now, how to add data? How to insert data in a vector? Have a look here. We are using the same vector here, iv1. We are pushing 20 elements into it, and then again we'll see what is the size and what is the capacity. Initially, we had not done anything. The size and capacity were 0, 0. Then we had reserved space for 100 elements. Size was 0, means no element is inserted, and capacity is 100. Now, after inserting these 20 elements, its size is 20, means you have stored 20 elements into it, and its total capacity is of 100, right? Okay, then as you can see, problem with arrays, once you have declared an array of 10 elements and you have stored only 5, say, then the remaining 5 will be wasted. So in this case, we can shrink the vector. We had reserved space for 100 elements in it, right? But we have stored only 20. At this point, it is showing size as 20 and capacity as 100. Now, when we'll shrink it to fit, then its capacity will also be brought down to 20, as you can see here. We'll shrink it to fit. Fit means reduce the total size of the vector equal to number of actually stored elements in it. Okay. Then how to print the values of the vector. We have created a function, right? Display direct IB1. So what that display direct will do, this is how it will work. You simply put a loop and go through every element of it, just like a normal array. It will be printed. So we are calling this display direct function. Let me show you again. It is displaying the values 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 up to 19, 0 to 19 values it is showing, right? Because we had inserted value of I into it. Now through iterator, how to display it? Let me show you. This is the second method. We are using an iterator, just like here we had declared. In this function, we'll declare an iterator. We'll set its starting point to be equal to beginning of the vector and its ending point equal to be end of the vector. And accordingly, we'll iterate through it and it will display the values. Let's run it again. This is the second case. In first case, we had used direct display. In second case, we have used iterator to display or iterate through the values of the vector.
सर दोबारा दसिए एक बार.
Okay, fine. There are two possible ways through which you can iterate through the values of a vector. First is direct method, as we do it in case of array. Right? You can see it here. We are using this just like a normal array. This is a direct method. Right? It will print all the values of iterator, all the values of vector. Second method is through iterator. I told you that for these different data structures of standard template library, when you are to iterate through the values of a particular data structure, you can use its iterator, its own iterator also. So what we have done here, we have declared an iterator for vector, as you can see here, vector, type of vector is integer, and then its iterator, we have declared IT. So through which values it will iterate? Through the beginning of vector to the end of vector, right? So IT's initial value will be the beginning element or the element lying at the beginning, and its last value will be element lying at the end of it. And through that, using just like a pointer, we will print those values. This is the display method using iterator. First one was display method using direct technique. The result is the same, as you can see. This is through direct method, and the second one is through iterator. Is it clear now, Vijay?
Yes, sir.
Okay. And next is, okay, rest of it we'll discuss tomorrow. Okay. We'll continue with this. We'll discuss a few more things are there. We'll discuss these things tomorrow. Okay, that's all for today. Do you have any questions? Any
No,
questions,
sir.
anybody? Yes?